Okay, so I've thought about your question for a long time, and this is the best explanation that I can come up with. That's more conceptual rather than mathematical. So, imagine the switch is open. You have to imagine voltage as some sort of pressure. And in fact, it is pressure because what does 18 volts imply there? It means that there's such a massive buildup of charge that per coulomb of charge, you have 18 joules of potential energy from here to here. So imagine that being the repulsion of positive charges. So imagine you have a bunch of buildup of positive charges here, and they are repelling, so they're all trying to go this way. When the charge reaches the capacitor, it charges the capacitor, and eventually it builds up on the capacitor. And now you have an equal tug of war. This capacitor is repelling the positive charges just as equally as the power supply is. And so you have an 18 volt drop across the capacitor. Why 18 volts? Because these two circuits are isolated, meaning that all the pressure is going towards, all the voltage is going onto the plates, all the pressure is going towards the plates, and the plate is countering with an equal 18 volts resistance. But what happens when you flick open the switch is that all this pressure, this potential, doesn't have to necessarily travel through the capacitor. It can also travel through this circuit here. And what this does is, since you have the same amount of potential, it lessens the potential on this capacitor. If you were to think of voltage as water pressure, imagine you have this wall right here, and you have some tubing with a little bit of resistance. If this switch were to be open, then all the pressure goes onto the wall. But once this switch is closed, or once this tubing is connected, a lot of the pressure can pass through this side circuit. And because voltage or pressure is passing through this side circuit, it lessens the potential of the pressure on this capacitor. We saw for that mathematically when we said that voltage is maintained along this track, so if there's voltage here, then this decreases. But conceptually speaking, it's the idea that this circuit bleeds off voltage or pressure that would have otherwise been on this plate. And as a result of a decrease in pressure or voltage across this plate, charge decreases. So it gives up charge. The charge give up of this capacitor is a one-time thing. So there was some original equilibrium of 18 volts times 6 microfarads worth of charge. The second it's connected, the charge is near instantaneously flipped, and then the equilibrium goes back to I think it's 12 volts? 12 volts times 6 microfarads worth of charge here, and it's static. So once again, there's actually still no current through this area.